All right, so we are a couple minutes after 11 o'clock. So Bryce, if it's cool with you, we are going to go ahead and get started on today's webinar.
Perfect. Yes. Thank you, everyone, for joining. So I'm Bryce Brewer. I'm with Grace Technologies, and I'm an IIoT Application Engineer. And today we're going to go into a little bit of the predictive maintenance system and talking about motor vibration analysis and what IoT offers on top of that. So we'll go ahead and dive in here. We'll go into the overview. So we're going to talk about current state of maintenance, what the GraceSense Predictive Maintenance System offers, look at the vibration analysis, as well as some of our solution providers out there like Anderson Controls and Safety Solutions. So a bit about Grace. Grace has been around since the early 90s, and it's a second-generation family-owned business. We do have global distribution and are a Rockwell and Compass partner for, I think it's going on 23 years. So we're happy to be able to provide the predictive maintenance side on top of our typical electrical safety solutions. So today we're going to talk about a bit of the problem that a lot of manufacturers are facing and what we can do to provide a solution for them. So there's increased competition due to efficiencies of scale and large automation systems throughout all of the manufacturing facilities. So this puts a high demand on uptime for equipment. So if you put a CapEx expenditure through and you want to guarantee that you're going to get the returns that you're asking for through high uptime. So we're here to help provide insight into your system to where you can take equipment down and perform maintenance tasks when you need to, not just when you have a scheduled PM or something like that. So the problem is a $20 billion problem. So across process industries, we're seeing $20 billion of unplanned downtime costs, and we're trying to help recoup that. And near and dear to Grace's heart is electrical safety. So 70% of all workplace injuries happen during reactive maintenance. So when the plant manager is breathing down someone's neck to get the equipment back up and running, shortcuts are taken in order to do that, and that can lead to injuries. So if we can avoid the unplanned downtime and have planned downtime, that's where we're trying to really provide value. One thing we like to point out is that this is not a silver bullet. So it is a part of a larger culture, so a reliability culture. So we're providing some vibration analysis, some condition-based maintenance, some preventative maintenance, but it requires operation excellence, for example, in order to carry out those tasks that we are saying need to be done, as well as root cause analysis to find the problem, and leaders who see reliability as an important role in their company. So it's not your technology that's going to get rid of all your reliability problems, but we're definitely one of those key factors. So the maintenance spectrum definitely ranges from your run to failure and schedule-based types all the way to predictive and prescriptive maintenance. And it is not a one-size-fits-all solution. So run to failure on a light bulb, for example, perfectly fine. Schedule-based for like oil changes and things like that, that is perfectly acceptable. But when we're talking about really critical motors and rotating equipment, pumps, fans, conveyors, those might need a higher level of maintenance performed on them. So one thing we like to suggest is a criticality assessment. So you can look at all the motors in your facility and determine what ones are most critical to our processes. And that's where Grace is really lying is once you identify those, let's go ahead and monitor those. You get your condition-based monitoring, and then add in more of the predictive side and prescriptive side of things. So a lot of people out there are saying that they are prescriptive, And so what I mean by prescriptive is that we're not just saying that we're experiencing an anomaly. It's that we predict that you'll have 6 months time before you'll have a failure with 80% certainty, and this is the task that needs to be done in order to prevent that. So that's where we are moving to. We're not there yet. I don't know of many people who are, if there are. There's a lot of people who are out there who will say that's what they're providing, but we're here to work with you to move you up the spectrum as we develop more and more technology and get more insight. So the IoT solution, in our eyes, there are 4 keys. So it has to be a comprehensive single platform. So we don't want, your vibration nodes and, vibration in one system that you have to monitor, and then you have your current and pressure and flow in another one. And, having to use all these different systems becomes cumbersome. So we want to provide a single platform to really tie everything together, and then be able to produce actionable information. So we're not just providing data, we're telling you what you can do in order to solve your problem. And then meaningful alarms and alerts, how you need them. So if that's a SMS text or an email telling you what needs to be done, we're happy to provide that. And then seamless integration with existing systems. So you have your PLC and SCADA system, maybe you want it in there, and that makes a lot of sense for many of our customers. So a solution should be able to do all those things for you. And so here's a look at the hardware in our predictive maintenance system. So I'll be going into each of these in detail, but on the left you have the hotspot monitor. So that typically sits in your low voltage compartment in switchgears or MCC equipment. And then you have a probe that goes and gets routed out to a connection that you can monitor temperature on continually. So it's kind of a complement to IR and a replacement in some cases. Then we have our field mount vibration and temperature node. So this is a device that sits out on your motor, pump, fan, your asset, and gathers triaxial acceleration information as well as your surface temperature, and sends that back to a device like the cloud gate there in the middle. So that device is the gateway in the network, so it gathers data from all the nodes and puts it into the system of choice. And the basic system, or what we typically suggest, is our maintenance hub, to where you can have that data visualization, analysis, alerting, and a bunch of other features we'll discuss. So a bit more information on the hotspot monitor. So with this type of device, it's kind of in a low frequency, high impact type area. So you'll have switchgear that run for years and years and years and never have a problem. But this when they do have a problem, all motion in your facilities is shut down. So it's definitely on those critical pieces of equipment. This is the big benefit. So it has continuous monitoring as well as view of inaccessible locations, which I'll show in a second. So here's a bit of how it works. So you'll have your hotspot monitor module that sits in the low voltage compartment, and then you route these 15-meter polymer fibers to the connection, and it gets bolted down at the bus bar or circuit breaker lug, whatever you have there. So we send an LED pulse down the fiber, and then there's a phosphorus tip on the end, which detects temperature, and then it reflects it differently based on the temperature that you see. And so that's read back at the head module. So here's an example of why you'd want something like this outside of just being a 24/7 monitoring. So you'll see that from the left, you have your IR window, and you can see some connections, but you can't see everything because it's behind guarding, or there's just not enough view from the window. So this can be on those connections that you can't see to either, as I said, complement or potentially replace IR in that piece of equipment. So moving on from the hotspot monitor, we'll talk about our vibration and temperature node. So this has a triaxial accelerometer on it. We do have 800 hertz bandwidth on our current option, but we are releasing in the fall a higher bandwidth option that's 4600 hertz in the X and Y and 2200 in the Z direction. But a big thing here is that you want to have long battery life. So we offer 3 to 5 years at 1 hour capture settings. So the device will sit out there, it will wake up once an hour, grab several seconds worth of high rate data, process that down, and send it off to our cloud gate or control gate. So it is a Zigbee compatible communication that's on the 2.4 gigahertz band, so it's also on IEEE 802.15.4, and we have 30-meter line of sight range between the node and the cloud gate. And it is IP66, and we're working on some other hazardous location rating, for instance, and things like that that'll provide value in those applications that require that. So this device can be stud mounted, epoxy mounted, magnetically mounted to the equipment using the stud that you see there. And by far our most common is a magnetic mount, especially in the first installs by our customers, just to get up and running very easily. And they could potentially put it on different pieces of equipment just to get baselines and understand the system and what the status is of their equipment. So other benefits that are somewhat unique to Grace is the edge processing. So this allows for longer battery life and lower bandwidth. And so edge processing means that we take that high data rate information and then we process that down into usable information that we send off to the cloud. So that's done, and instead of sending kilobytes of data, we're sending bytes of data every hour. So that prevents data glut. So that's a definite concern since we're on the 2.4 gigahertz with some of our customers, but we're really at such a low level that we're not going to interfere with any system. And then the SPE can also have special firmware that's ran on it in order to do advanced analytics. So this allows for us to build in the future to be able to push over-the-air updates to the device as we get more and more smart. So the banded Fourier analysis will go into detail when we talk about vibration, but that's really what makes motor vibration analysis possible. And then burst mode would be if you are detecting an anomaly and you want a full-time waveform, we can send that from the device per your request. Another nice feature is statistical oversampling. So this would be really important on like robotic applications. So for example, if you have a robotic arm motion that happens and it takes 15 seconds to complete, and you're sampling randomly within that cycle, you'll get a random data trend. So it might be unloaded at one point when you sample, and then the next time you sample, it's at the highest loading capacity. So you'll have a noisy signal. So what we would offer is the ability to quickly go in there and say, well, I want to capture data for 20 seconds, and I want to average that out over that time span. So you get your mean, min, max values and can trend those much easily and get rid of a lot of that noise. So moving on to our panel mount nodes. So we kind of have 3 flavors here. So we have just simply a node, and that node is just a device that can bring in a variety of third-party hardwired sensors. So if that's accelerometers, RTDs, thermistors, current clamps, anything like that, we can bring into the back of the device, and it's configurable with different I/O. Then we have a cloud gate. So that would be, it would take data from the nodes and put it into our maintenance hub or a private server if you needed that. And then we also have the control gate option. So the control gate is a unique feature that we provide that allows you to put it on the control network And you can do just the control deployment, or you can do dual, to where you have information in your control system as well as to the cloud. So you might have certain parties that are interested in data from the control system and building out screens there, while you might have more in the operations side, or management level might want to see alarms and alerts and information at the cloud. And so that's kind of the three different options, but all of them you can add in hardwired sensors. We have the ability to connect to the cloud via LTE, so AT&T and Verizon are our options. So that's a great way to get up and running before having to involve the IT department with a Wi-Fi style rollout. So definitely something we suggest on those beta applications. And then as I mentioned, they do have the Zigbee compatible communication, and we can bring in also a Modbus RTU, and then we have the control gate can talk to the control system using Ethernet IP or Modbus TCP IP. So here's a look at just the different options. So we build these all in-house at Grace with quick lead times due to the configurability of our system. If you're familiar with Grace ports, we have 15,000 different SKUs, and we ship all those out in 3 to 4 days. So this is not something that is new for us. We've been doing it since the early 90s. So, and you will notice if you are a Graceport customer, that is a Graceport housing that we typically use. So that gives us our panel mount option. So, but you can go through, you pick your sensor interface options you want, you pick the communication style that you want, and then we build that up using the correct PCBs in-house to provide the application-specific control gate or cloud gate you need. So we have mentioned the maintenance hub. So this is our cloud offering. It is hosted in Microsoft Azure. It's encrypted end-to-end, so it's built with security in mind. You'll see quick snapshots of the screens there. So you have your typical dashboard, but that's completely customizable, and we'll work with you to customize that to meet your needs. And you can see you can graph it, trend it, take a look at different data and how they relate to each other, as well as you can then customize alarms and alerts that get sent out. So there's definitely a lot to talk about on that, and we do have great videos. I'm not going to go into too much detail here, but definitely look into some of our video offerings that do provide more information on that. So we do believe in data freedom. So we're not going to tell you how you need to have your data within our system. We want it to be in the system that you want it to be in, to where you can be as impactful as possible with it. So we're not trying to corner you into our system, but we provide a variety of different options that we'll touch on now. So this is the typical rollout that we have for a good portion of our customers, at least definitely in the start, because it's very easy to get up and running. So you'll have your node that sits out on the motor, and you can have additional nodes that are bringing in hardwired sensors, or our hotspot monitor can be brought in for those temperature critical connections in the facility. And then that's pushed up via Wi-Fi or LTE to the cloud. So that's the standard, but we also have this with a control gate. You can also push it via Ethernet IP to the Allen Bradley network, or you can use Modbus TCP if you have a different provider. So it makes for a very easy integration using Studio 5000. We're working on the custom AOP that'll be out in the fall that makes integrating a breeze, but we do have the ability to do it now without the AOP, and we can help our customers with that. So a different solution that you might want to employ is a database-to-database connection using an API. So a RESTful API or MQTT, for example, you can bring that into, say, a CMMS system that you're already using, or your SCADA system. So that is an option. there's multiple ways to get the data out. So you can also, as I mentioned, use a hardwired connection into a control network. Another thing is we do allow for either a locally hosted cloud, a private cloud, or just to have an on-premise server. So that's if you can't let data leave your walls, and that's within the facility's guidelines, we can provide a solution for that. Another unique thing is we're not just here to sell you, some hardware. We're here to be a solution provider and work with you hand in hand to get the system that you need and get the maximum impact out of that. So what we offer is, we'll sit down with you, find out exactly what the asset layout looks like to where we can provide a system that when it arrives, we can be there on site to help install, or it's at least labeled to where on motor 1 is this node comes in, it's labeled as motor 1. You go and install that on the motor, and then it automatically routes the data as you need. So we're definitely there to make this as easy of a deployment as possible. And so through that, we also do onboarding consulting where we'll meet with our customer once a week for 12 weeks and just go over for an hour questions. We'll go and do training. We'll, help set up alarms and alerts. Whatever is needed, we're there to help. And so as part of this, we also have Anderson Controls and Safety Solutions. Dan will be a great asset, which we'll talk on later, but he's a critical part of this as well. So then we're going to jump in now that we've talked about some of the hardware stuff. Let's dive into the vibration analysis overview. So why are we talking about vibration? So almost all critical equipment have a major rotating component. So you can take any large complex system and break it down into subsystems that are a motor and a fan, or a motor and a pump. Any number of things can be really just boiled down into their component parts. And so the rotating components are constantly subjected to mechanical strain, friction, and fatigue. So this just wears it down over time, and that's often a complex and expensive thing to monitor and to maintain, and it does require downtime anytime you want to perform maintenance on it. So we need to bring it down when we see fit, not when the equipment decides it's done working. And so with that, we provide as much warning as possible that a piece of rotating equipment needs to be maintained. So with that, we'll dive into the design to failure curve. So the design to failure curve it used to be the bathtub curve, but there's a variety of ways of looking at it. But so the functional failure is at the far right. And so functional failure does not mean necessarily catastrophic failure. It just means that the motor cannot perform the duty it was intended to do. And before that, we would typically see a temperature increase. So before the functional failure, there is an increase in temperature due to, if it's a misalignment at the coupling, you would have that, or bearing issues would cause the bearing to overheat and then break down the grease in there. But even before temperature increase, we'd see a current draw increase on that motor. So we can monitor the current of the motor, and then if you start to see it trend upward, you would know that there's some kind of binding inefficiency in the process of making this motor work harder than it did before. But what we're focused on is the vibration side. So this happens well in advance of any of the other symptoms that we see here, the current draw or the temperature increase. As vibration, it'll detect, if a bearing is starting to get, some damage in the raceway, just little spalling, or, if a ball has a dent in it and things like that, the vibration analysis can pick up on that. So that's why we're really encouraging this, because it gives you the most warning that's really possible to address the issue. And so I do like to point out it is more than just amplitude. So you can't just look at an overall signal and be able to say, that what the problem is. You'll know that a problem exists if you see a much higher than normal increase on your overall. So if you see 0.5 inches per second, like that is definitely indicative of a failure. But that doesn't mean that always we're going to see a large increase in your overall levels there, that there isn't damage occurring. So at higher frequencies, like in the bearing level, you don't need a lot of amplitude increase for it to be an issue. So it doesn't show up in that overall level. And so that's why we have to really gear this towards the motor and provide the analysis on that based on the motor condition. So if we move from the time domain to frequency domain, so what this means is we're just going to walk through what happens in a vibration analysis for a motor. So the first step is that we have to take data that we capture over time and bring that into a way that we can look at it in regards to the rotational speed of the motor. So this provides the right context to be able to analyze it. So if we look at the overall here, you have your machine of interest that a node, one of our vibration temperature nodes would be on. And then we grab the analog voltage output and digitize that and send that to the processor to perform an FFT analysis. So FFT stands for a fast Fourier transform, and it's what takes us from that time domain into the frequency domain. And so this is not something that's new. It's been around for decades. It's tried and true, and that's something we really like to point out is a lot of solution providers out there will say that they have advanced algorithms that are there that is their IP that no one else can do. And really that isn't the case when it comes to the FFT analysis. It's just math and science that has been tested and have ISO standards based on since I believe the 70s or potentially even earlier. So we're here to tell you that we're going to provide that value for you in performing the conversion into your FFT analysis, and as well we'll evaluate against those ISO values. So it's really just taking what's already known and making it easy to understand for the user. So the way we do that is once we detect an anomaly, we start to narrow down on what the potential fault is. So the ways you can do that is by looking at frequency. So is this below the turning speed of the motor or subsynchronous? Is it at exactly the turning speed of the motor, so it's a synchronous fault? Or is it a harmonic, which is an exact multiple, so it's either, it's exactly 2 times the running speed. It is not 2.048, it is 2 times. And then non-harmonic is anything that's not an exact multiple of that running speed. So if we group it into those, we start to narrow it down, and then we look at the direction. So what axis is this in? Is it the radial or axial direction? So that some faults only occur radially, and some faults only occur axially. And then there's other faults that could be either or. So that just helps us as another tool to rule out what isn't the issue. And then finally, diagnostic testing is performed in order to really get at what that key problem is. So that includes a phase analysis or a time waveform for, say, a gearbox, and ultrasonic for any of those high frequency type events. So here is a great look at how we do that. So this is a vibration periodic table. And so this takes all those things that I was mentioning. So you take is it synchronous? If you have a synchronous fault, it's one of these things. It's not any of these. So you can remove those from your troubleshooting. And same goes for if it's subharmonic. If it's harmonic, it falls into these. So that's kind of grouping it in frequency. And then we take it one step further. So we determine it was a synchronous fault, but maybe it was in the radial direction. And so it would be one of these 4 items that you'd be most interested in looking at. If it was axial, then it would be potentially these. And then ones that can occur in either are in orange. So this is just a really great tool that we incorporate into our system in order to help provide insight into what's going on. We're not just going to tell you, okay, well, there's a high amplitude experience on this band. There's high amplitude in the synchronous, and it is probably one of these 4 things. So you can go out there with a game plan and as to how to fix it. And so what does IoT provide on top of your just normal vibration analysis? As many facilities do have experts on staff, or they contract them in to do, routes, or when needed, when a motor is not performing correctly. So the big thing that we provide IoT in general is just the frequency of sampling. So in a top class facility, you might have up to a monthly vibration captures on your critical motors. More often it's quarterly or sometimes not even that. But when we take hourly samples, we get 2,000 times the number of samples than if you do it monthly. So it's obviously a wealth of information that we can start to capture and provide like a history of what's going on with this equipment. And then it's permanent and wireless. So that makes for an easier deployment with the wireless system. So you don't have to run wires everywhere, and it's on 24/7 looking at that. And then we provide great ways to visualize the data. So you might have a vibration expert who goes around and captures it, but it takes usually a decent amount of work to analyze all that and provide reports. So we provide an easy way to see the data for our customers. One thing we like to say is that we do not necessarily replace the analysts, the vibration analysts, but we augment them. So we're not saying that you can, all the vibration team that you have on staff is just gone when you employ this system. It's saying that they don't need to be going around collecting samples every day on equipment that's perfectly healthy. So if the equipment's healthy and you're taking a sample, it takes a long time to get those samples and process them and review them. So we're providing an easy way to have those equipment monitored, and we'll tell you when there's a problem. And then your analyst can go out there to that equipment and do a full diagnosis on it so they can detect any faults that are there. So that's really what we like to say is that we're going to provide you with insight into it, but it doesn't mean that sometimes you're not going to need an analyst to go out there and do the work. And so what we provide is a cost-effective solution with analytics provide actionable data. So we do capture that data at the edge, as I mentioned. So it's processed there and sent in just the banded information. And so we also make vibration analysis possible for those who are not vibration experts. So you don't have to be a Cat 4 certified vibration analyst in order to look at some of this and be able to glean something from it. So if you look at the right, this is kind of our vibration analysis suite. So you can go in and very quickly set up an asset by choosing what type of machine it is. So in this case, it's a fan or blower, but maybe it was a direct-driven fan or a compressor or something like that. So this changes the ISO values that we're looking at in order to determine, is this healthy or is this not? You can put in other information about the system, what speed it is at, that type of thing to help, get that analysis done correctly. And then you go through and you select, so these are the different nodes. Those are the serial numbers that we put on the different locations. So you can really visualize what your system looks like and put that into here to where you can get data on it and then evaluate automatically. So basically right here, what we're seeing is you put all these on here, and then it'll automatically set up alarming on every band. So we'll alarm out on each one of these nodes. If any of them on any axis report, high subsynchronous vibration values, we would send out an alert and tell you exactly what channel it was on, what we think it is, or at least give you, a starting point. And so it takes there's probably 100 thresholds that we're employing here, all with just quickly adding nodes. So we can send out for a warning level. So at this, if we exceed here, that's a warning. That means that, it's not bad yet, but if you're planning on say a downtime at your facility, it might be a good time to go ahead and perform maintenance. But once we get up into the danger level like here, that is definitely, we're at the end of life for this piece of equipment. It is experiencing very high vibration that could lead to failure. So that's what we offer very quickly. And so that's the cloud solution versus your on-premise, or versus your route-based. And so from here, I'd like to take a moment to let you guys know about some of the resources at hand. So Dan with Anderson Controls and Safety Solution, he's been involved in a lot of these projects, and he brings the technical expertise on both our system and the equipment within the facility. So he's there to make sure that we have a successful project. That's from site audits, looking at your piece of equipment, helping you determine what's the critical ones to monitor, making sure we have good wireless communication, and then what are our integration options to get you the data where you'd like it. So I don't know, Dan, if you want to chime in here and introduce yourself.
Hi, everyone. I think Bryce did a really good job of kind of introducing the, some of the additional services that Anderson Controls can provide to IoT customers. But I think one of the things that Grace does really well in general and kind of differentiates them from some of the other vendors in the marketplace is, their network of local support. And just like Bryce said, when someone gets to the point where they want to start looking more deeply at doing vibration and temperature monitoring, and utilizing a system similar to the GraceSense system, that's where we're able to go on site and really work closely with the customer to help them implement a system that works for them, confirm its viability in their facility, and then provide, technical support throughout the whole process as they're getting up to speed with any kind of predictive maintenance.
Perfect. Yeah. So, Dan, we've been working with him for quite some time. He's definitely a great asset out there. Definitely one of our better boots on the ground. So you guys are lucky to have him out there. So we appreciate what he does for us out there in the field, making us more impactful. So with that, I'd just like to thank everyone once again for joining. I know that was a lot that we covered pretty quickly. So I'd like to open up the floor, see if people have questions. We'd be happy to stay on and answer them. And so, yeah, is there anyone out there who would like a question answered? All right, I'm not hearing much. Nicole, I don't know if you have anything that you wanted to add here, or let them know where they can potentially see this or get more information.
Yeah, absolutely. So thanks everyone who participated today in the webinar. I'm going to be sending out a post-webinar email. It contains a survey. If you want to take the survey, just let us know how we did. That would be great. The email also will contain a recording of this webinar. So if you need to go rewatch it for reference, if you have any colleagues or coworkers who weren't able to make the webinar and still want to check it out, there is a link available, and that link will also be on YouTube under Rumsey's YouTube channel. But that's all I have. So if anyone has any questions, please feel free to unmute yourself and shout them out. But other than that, I'm good. And Bryce, if you're good as well.
Yeah, I'll stay on the line, make sure there aren't any questions. And if not, we'll definitely look forward to being able to answer them offline if that's more appropriate.
Great. Thank you so much.